No, I'm not. I know. This is why I record, because I totally know that I like the idea that you have the flexibility to work on what is most pressing for you, and this is just captured and when you can get to it. So that's my concept. That's an idea that I like. So let's see. So yeah, I've got my drawings opened up. I'm ready to start dimensioning. I'll probably end up having to open pretty much all the parts for this as I go along. I was just going to show you really quick that the final the notorious part of the discharge chute. I have those things open right now, the part assembly, the assembly, and that specific ignorant part. How I would choose to realize if I really resolved the issues with this. This is I would do what I would flex the part, and this is what I kind of do in that video that I made for Nathan. But it's a good thing when you've had difficulty working on something, but you think you've solved it, then you just do a little flex to see if you're getting the results without errors. And the way I would flex something like this, it's been notoriously picky for me, is I would go into that part assembly, and I might just do like a suppress on the cut. And if I would suppress this, I should see that, okay, yep, the cut goes away. The part's kind of how it was. And then if I follow this out to the assembly that was exported from here, there it is. If I hit my update, it should throw back in that without any errors or out any crashes, essentially, like mine was able. It just kind of, and then I can go to the part itself and watch for it to accept, and it did. It accepted that suppress cut now from clear back upstream, I should say, clear upstream. And then if I go back into that part and I say, yeah, I just wanted to flex it and test it. That seems to be operating. When I do a spot update here, it throws back in the cut and my part accepts that and my flat pattern still works. So this is how I would flex this to make sure I think I have finally resolved issues with this. And it doesn't mean sometimes when I check stuff into a vault system and then check it back out, here comes these problems again, and I got to rework parts a little bit. So it was interesting when Nathan even sent me his files. When I opened them up and tried to do what we've been doing, I didn't get any errors, but then I still chose to make a few adjustments to the part assembly. Yeah, flexing is just me going to where I've put in details on parts, like that's clear back here where I'm checking fits. I would suppress a feature. This is the one I'm suppressing because I'm picking this part specifically, and I would just suppress, which I use suppressing for stuff like this. I might use the other reason why I might leave a suppressed feature is if maybe um, I have like if I was making say I'm making a 12 like this was all done and it was a 10-inch screw conveyor. Maybe I come in and they want me to do it. I want to use all my solids and change them to a 12-inch screw conveyor. Um, when I start making some of those changes, and then maybe the 12-inch screw conveyor has a few different details to it, but what I've chosen to do is like copy the 10-inch. Pretty much, I've copied the 10-inch assemblies and all of its parts and solids. Like I've made new copies of all of that are all tied together as kind of a new copied system that I'm going to change to 12-inch. And then it has some additional different features. And so it would just be that whatever I copied in, maybe it has features that I'm not using on this assembly. And then I might just choose to suppress those uh, and leave those as a suppressed item. And that's like one reason why I would leave things suppressed. It's like they came from another assembly. Eventually, if I really was happy, I would probably try to delete those out because my to me my best um just I guess if I'm doing my best work, I'm going to try to make sure that I don't have a model assembly like this with a bunch of stuff underneath the end of folded, or just suppress stuff that's not doing anything in this model. Eventually, I probably should just clean that up clean. And the only reason why I might leave a few suppress is just maybe because where they came from, I don't want to totally get rid of them. There should be a reason for it. And if it's just because I'm trying to turn it off because it didn't work, well, then I should delete it out. But anyway, I also use it for this, which is just like, oh, let's use this suppress idea to flex something and see if I'm getting this communication loop established where it accepts stuff like this. Bam, it accepts that unsuppressed cut now, or that suppressed cut. And when I unsuppress the cut, I get good results and I don't get errors when I do these updates. And yeah, so that's yeah. It still says that to you? Oh, oh yeah. I think what you're going to want to do, which isn't going to affect me too much right now and what I'm going to do, you're going to want to watch that little 8-minute video that I posted yesterday. It's only 8 minutes. It's the last one in our in-class videos at yeah, from four. It's the only video I posted yesterday, 4/8, and it's only 8 minutes. Should be an 8 minute. I hope it's an 8 minute fix, but it might make you have to do some model adjustments to this particular file right here. Yep. Yeah, I'm just going to do some drawing. So I'm going to jump in now and do some drawing stuff. Um, and I'm just starting with my first drawing. I definitely want my descriptions all filled out. So that's one thing I want to get filled out. That's really the only thing missing. So you can just click through these. These are all also how you can open parts. Like that's if I just double click in my parts list, it'll open up. Um, as far as this being just a single part, I would want it to just have its material type here. So for the properties on the description, which is what's going to fill out in my title block, I'm just going to, and I'll just use all caps. I'll try to remember that all day today, but it's going to be 12 gauge, I'll abbreviate, stainless steel. Yes, I'm going to copy this because I'm going to go paste it into a bunch of parts. So I can update the physical. This is something I can go ahead and update that while I'm in here. And then I'll just watch before I ever make a PDF. So when I really want to watch that my uh, properties, the masses have been um, updated. I'll say okay on that. And I'll just bounce over here real quick. And that one has now got me a description. I think these are all just going to be their material type descriptions. The description on the assembly will not be a material type description though. I'll just use some words and I'll see if my view label is set up how I want it to be. I thought I had, anyway, we'll see. But I'm going to go through these parts and add their description. So I'm just going through my list and updating that and maybe the physical properties. And then I'm back to my drawing. Once I have a drawing, I generally on my I work like with my drawing over on the left and I let parts and assemblies up. Generally, the way I work with my all my open files there is I have like my drawings on the left, and I have my assemblies, and I have my parts kind of staggered out. So just so you know, it's not a big deal, but however you want to organize it, you can always just look for the IDW icon or IAM. This one here needs a description, so that's one thing. Yeah. I don't I don't know. I don't think I'm going to add anything else to these eye properties at this point. So this one is 3/16 plate, actually. 3/16 stainless steel plate. So I'll just come up with another abbreviation for that. 3/16, I'll use fractional. If you were to look through a materials catalog like that Pacific Seal manual, I think you'll see that their plates are usually designated fractionally, thickness fractionally. 3/16. I'll just put stainless steel plate. That. And part 10 is also 3/16 stainless steel. Did I copy? I don't know if I copied that. Nope, I didn't copy this. Let's see that. I don't know if I updated the other one. Sorry, I don't know if I updated this property real quick. 12. You can open it from there too, but I'm just that. And that one is 3/16 as well, yeah. That one's 1/4 inch plate for the end plates. 1/4 inch stainless steel plate. That one's 1/4 inch as well. Well, that at least fills out my. Just gonna shorten this up a little bit.
What do you do if you're missing a part on your parts list?
Right here, you're missing a part. Then it's not in the assembly. So that either you haven't like sent that component to that target assembly or
Main thing I had, but we designed all those lumpings as a part assembly. So if you imported that part assembly, it would count that whole thing as one part, even though it's like.
yeah.
Like you select one of them, maybe lots of them get highlighted, like your bottom and lowest. Well, that was good.
Are you looking at this assembly that's on the print here now? And maybe did you not send them to the did you send them to this target assembly? Those two end plates? Oh, they're on your assembly, but they are not showing up on your parts list. Oh, I don't know. Let me take. I actually want. I'll come take a look here real quick. You'll be on my docket to come after I quit running my mouth here. But I'll see if I can get that repaired. I have seen that before, so I need to just jog my memory on what we got to fix that. Yeah, so I'm just gonna balloon all of these items here where they're easily identifiable. Only one balloon per part. No bueno or good? It didn't work? Okay.
Here was hers. My first thinking was the milk, but maybe that's the common denominator.
Yeah, I'll put you on my to-do list too to see. Did you say you did get your parts list, Kelsey? Was it just by deleting and read? Okay, okay. It just seemed like it wouldn't accept any of those updates that you'd already done to it. Yeah, so that's a good lesson learned. I'll just show it. I'll show everybody what I was. It was just an issue where parts are clearly in my assembly. Parts clearly look correct. They're just not on my parts list. When in doubt, reapply your parts list. So just delete it and replace it. The other thing that what I looked for first on when we make components from a part assembly, we could maybe accidentally toggle off. You'll see this thing that maybe says normal, which is kind of its BOM structure, its bill of material structure. And let me show you what I looked at for Kelsey here. I had her drive down to this part, and then and then I went and checked on this tools. We haven't done this yet at all. We haven't messed with a few of these other tabs here at all. But tools has this document settings. And if you click on this, this is kind of just peering into this particular part's document settings. And one thing that does sometimes get toggled, well, sometimes I use this strategically, but on this bill of materials tab, so from document settings to bill of materials here, when you're creating those components from a part assembly, you'll notice that there's a column that you could toggle this on differently. Um, and these are the options you'd have in that column when you're like you're naming your new part, you're picking where you want it to go in your folder structure. If normal is normal, and it will generally normally show up on my BOM on my parts list. Um, Sometimes there's parts in an assembly that I don't want to, and I can't. If I thought of a scenario, but um, well, one thing is, well, anyway, you could if you choose like sometimes we choose inseparable or phantom, and they won't show up on your parts lists. And so I checked hers to make sure it wasn't toggled onto phantom because for sure if this ends up being accidentally bumped to phantom, it will never show up on your parts list. And the reason for that sometimes might be is that it's um why I would do that kind of, I'm trying to think of why we would do this. For sure, it would be sometimes I have issues with, I don't have to change that right now, but sometimes I have issues when I on this solid showing up on my parts list because there is this like connected loop to it. And sometimes I have to go into these like kind of these base solids and stuff and toggle them onto Phantom so that if they sometimes are populating strangely coming through on parts lists. And if you toggle them to Phantom, like then that usually turns them off there. That's one use of it, but I have a few other uses if I could think of them. But that's kind of next level, getting good with your parts list management, maybe. Yes. So it doesn't show them in there at all, parts as well for you. Oh, I don't know. So this is fun. We have like, it's hard to, okay, back to it. Here we go. What do we got? I don't know where I am. What was I doing? Ballooning. That's all I'm doing is ballooning.
Yeah, who else is legal and both? Hard to do it.
Nope, just balloon one. But where you put your balloons doesn't matter to me. I to me, I just a balloon line is like a leader line. I just try to avoid like straight up and down or perfectly 90 degrees. So I kind of avoid vertical and horizontal balloon lines. And I slightly avoid my balloon lines being like matching, I don't know, a line of the from the assembly or something. So just try to make it so it stands out a little bit. But where you choose to do it doesn't matter. Just make sure you capture one. A real common self-check companies will make you do is print off your prints and they may have a color coded system. They want you to mark that you've checked like that every part on the parts list shows up on the balloon somewhere. That's a really good check to do. That you don't have things missing that are not ballooned. So yeah. And I definitely have some hidden features here on and I try not, I mean, I would say like I'm gonna put this one in here somewhere. It might be kind of at a weird angle, something like this, but because I'm just going to try to get to where I can see it good. I definitely can reach across like this. I'm going to balloon this little part that I can get here somewhere, point to it. Maybe I would try not to reach like all the way across to balloon. Maybe I would try to, try to simplify your ballooning and your pointing a little bit. So these ones are hard to see. Like I really, I'm gonna like if I were reading this, I'd be like, well, what is that part five? I see that it's not part eight or part three. So it would make me want to go like look at, well, it's part five. It says it's 3/16 plate. It would make me go back. If I was the one reading this drawing, I don't get a real clear view of that. And there's two of them. But once I went to the part sheet and looked at it, I'd be like, oh, that makes sense. It's the flange on the back side of this end plate. So um, and before we've used some stacked balloons. Here, I'm probably not going to use any stacked. I generally use that with fasteners more than I do parts like this. And so then I would just look through mine and say, can I count to number eight? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I ballooned all my parts because I can count just by this view is that. I'm gonna do a description of this. I'm actually just checking my view label here. Like if I go down to the next sheet, I'm surprised my view label isn't like this. Like my part number, I don't. Oh, it's probably because it's the isometric view potentially. I might do a little trick here, but because this is the view label I would like to show up, and my template might not be set up to add all those parameters to the view label on the isometric view, but it does on the orthographic views like this. Because this is the view label I like. It's got a part number, scale. Once I fill out a description, it'll have a description and then it'll have its mass. So I'm kind of looking for a complete view label, and I'm not getting it on this particular sheet. And I think it's just because I've added, if I edit this view, I've added, it's an isometric view and I've added this view label and this is as simple as it is. So I might say, I'm going to toggle that one off. Because what I would really look for here is projected view. I really can't project from that, but I can say, come back and take a look at that thing, come back in here. place maybe a base view of just the front view. And maybe I'll scale it about the same. I'm not going to put this on the sheet. I'm going to cheat a little bit here. But I'm going to add its view label, which I think like that. Yeah, that's the view label I actually want on this thing. So I might steal it like this. It's kind of a hack method. If I delete it, I think I'm going to lose my view label. So I'm just going to keep this out here. This is all that's going to plot and print. And maybe I'll come up with something, but this right now it's just a hack method to get the view label that I really want, which is that one, which isn't. Yeah, that was the assembly, and I just placed like my littlest view of my assembly, which is like my front view, and then I stole its view label. And so I'm not saying I always do this, but right now, I'm thinking hacky a little bit here, and that's a quick hack right there. There are times on my drawing sheets that I do have stuff floating out in this model space. And so I've done this before where I've needed like a section view, but I don't need the other view from the section. I just need the section. So I like place that view, section it, and I bring my section view onto my drawing. And then I have that thing living up there that if, to the person making it, it doesn't make a dang bit of difference. If they only have the PDF of this to build it, they have no idea. To the designer that gets back into there, they're like, oh, I see what's going on, or something's going on here. So. That in mine, it's the flange behind it. And your numbers don't have to be my numbers, so don't change them. Just let the natural whatever numbers you know are showing up. But yeah, that is the flange. And I zoom way in so I can be like, yeah, I'll hook it to there so it'll pick out the right number. So sometimes you got to get way in here on buried parts so you can get to an edge of that actual part. But yeah, yeah, yeah. Yes. Just so you know, we're going to be modifying that part in the future. But well, let's just focus on drawings. We can focus on some details next week. The housing will never end. I'm really anxious to put a screw in this housing, or otherwise this is worthless. But but not really. It is important. It's the housing. Um, so I just need a description on it to show up, and it will show up here. So I'm just going to say that this is the. I'm probably going to give it a little bit of a description. That's so I'll go to the iProperties on it. This is on the assembly and its description. I think I'm gonna call out the size of this housing so that somebody could easily identify that this is a 10-inch. So it's a 10-inch, which I think I can put inch, screw conveyor housing. And I could abbreviate some of that potentially, SC housing, if my people in my industry knew that, but I think I'll just leave the whole word here. And I'm gonna update its physical. Oh, it's already been updated, so it's good. And then I should fill out that last description there.
Quotation saying it's 10-inch, not 10 foot.
Yeah, because actually what I'm identifying is the diameter of the screw conveyor. Yeah, so it's actually 8 foot, but that's an interesting. That's a good note. Uh what it wait, what oh, pound mass. Oh yeah, yeah. Yeah, that's pretty heavy, huh? Yeah, this is what's super critical for people to know is like, hey, let's go pick up that screw conveyor housing. And you're like, wait, it's 149 pounds. Let's go get a forklift. Oh yeah, that's interesting.
Well, I think already yours is great.
Excellent.
49.75 is the same as that.
Oh yeah, me and Riley are definitely correct.
Someone knows how to follow that.
Yeah, that is kind of interesting. We'd have to.
You guys think
Are you?
deal or-
Is your housing on GLP-1s or something? You've already lost 4 pounds. The old style of losing weight, that's so outdated. Just inject yourself with some serum and you'll lose weight.
Off this healthy potato.
That's right.
Like way high in starch.
Mine's organic potatoes, actually.
So this I like, and then I just need to fill out Yeah, mostly that I need the title, and I still have left this template to be right here, editables, where I'm going to fill out the edit sheet title. And so I'm just going to put essentially, I think I'm going to put the same thing that's on my description for that, which is a 10-inch screw conveyor housing. You could even just say housing, but I mean, we could say I'll just say it if I have room for it. Yep, I'm edit sheet. So I'm just over here in my model or the model browser for the drawing, and I'm right clicking to get to this edit sheet menu. This is how I've set up the template so that I can. I think the default on a lot of these templates is once you name one sheet, it's going to name all the sheets the same. And so I went in here on one of the last template modifications I made earlier last 8 weeks, I think, and I had made it so we still have to spot name our individual sheets because and this is just my preference. A company will always be their own preference. Mine will be every title of my sheet is going to be likely different, except for I will have like some that are. Uh, well, I'll show you how it goes. But like this one, I'm gonna call it 10-inch screw conveyor housing.
Use the print. They won't.
I It won't let me do it. Oh, it's gonna tell me that is not, and so then it just bails on that. Yeah, so don't. I think just 10 will be fine. Yes. So in the event that yeah, it doesn't like some symbols here, right? So 10. If I choose a title that's too long and doesn't fit in the title block, then I will definitely change it. Some of your drawings, one of my things was like, oh, just rename your drawing number, which can cause you some issues, especially in Inventor. On CAD, it won't cause you too many issues, but just want a title that fits in the. Hence the reason why I did think through this when I thought, what is going to be my drawing numbers, and that's why I came up with my ISU, your initials, and that because it fits nicely in the title block without running across the rev block. So technically you can have a pretty long title and still fit there. But yeah, that's 10-inch screw conveyor housing. I think I've told you as we continue to build out, this likely will end up on a sheet even further up. So maybe I'm not going to fill it out yet here. I'll just keep it as a placeholder. Usually for me with my revision history block, it's one of the last things I fill out just before I send it to production. I just make sure it's like my last check before I'm going to, send my email out that this job is ready for to produce. And I just make sure that I've toggled those dates on when I sent it to them. And so likely they don't match here when my drawn date or whatever, but I definitely want my date that I sent it to them to be correct. So I usually don't fill that out till pretty much I'm ready to PDF that thing and be done. And then I make sure it's the accurate date that I sent the PDF. So I'll just leave that. So this is kind of how I'm going to go build out my other sheets. So this one won't contain any dimensions, just strictly items. And I do have, I've got to be cognizant that revision history may need to grow, and I'd have to remove my stuff around, but just make sure don't have any major interferences here. I like it. It's good sheets. The next sheet is a kind of a dimensional sheet for that same assembly. And so to me, I'm probably gonna I'll probably I'll go back here. I think I'm gonna steal this title, and I'm just gonna name my next sheet this same title. Actually, I'm gonna control copy this, and because this is still that same assembly, so I'm gonna keep it the same sheet name. I don't even have to really put a number on it or whatever. It does kind of have a unique number that it's 2 of 10 right now anyway. So I'll just say edit sheet. This sheet is also just the 10 conveyor. It's just the same, pretty much the same title name. When I have parts, it'll just be 10-inch screw conveyor, or I might even just say housing parts on my next ones. Simplify it. And I could have multiple sheets that just say housing parts, and then a housing cut file, or it probably won't even say that. It'll be like the material size cut files, what some of those sheets will be named. So this is this sheet, and this one I will apply some dimensions, but they're going to be dimensions that are mostly most appropriate for the assembly. So not necessarily, I'm not going to worry about the hole patterns or any of that here. I just want some general overalls, which I'll start with wherever I want to put them. That I've got this height, and these should be set to be jumping at it. Maybe that's the 3/8 one. And I think for my general assembly prints like this, I'll keep 2 decimal places. When I get into machine parts, we don't have any machine parts yet. These are really all these parts will be laser or plasma cut or some kind of like our glow forge. These will be cut on a system that can cut these materials like our glow forge would, and then they'll be formed after that. So these are not machined parts. These are all cut parts. Let's see. So I only say that because when I'm probably doing the parts detailing for these, I think two decimal place will be fine because they're going to be a cut part from my model. On the machining prints, I'm going to hold a little higher level of accuracy when we get to those and increase my decimal places. So I need that. I need an overall width. So here I might even pick like my outermost, like to me on an assembly, what's handy to know is that this, like at its outermost features, the thing that's the dimension that it would be. So I think of these like overalls. You have different dimensions. I might have it. I have the wrong overall.
When I got the wrong place, I got the same entry.
Mine's 16 and a half overall, and that would be looking at the tall. That's actually clear back to here is what I'm really picking up. 16.69. Yeah, we can that's interesting. 16.69. 16.69 isn't quite a metal thickness off, but no, that's good.
You're drawing.
I don't know why my weight would be.
Oh, I see.
And have different dimensions. Yeah. Yeah.
It's gonna look the same as math.
On that particular
And math, same as my sizes are different though.
I'm telling you guys,
that's true.
both you guys.
It would
I know Matt designed this whole thing, but
no, like it is interesting to see. It could just be so like right here like this. Yeah. Yeah, this starts, isn't it funny? This is when you get all these gut checks when you start dimensioning and you're getting things that you're not expecting. So I would say don't panic. What we can do is apply the dimensions and then we can go back through and analyze the model and see where yours is different than mine. In fact, when I upload mine, anyway, I don't know if I can upload, I might be able to upload all my stuff. Uh, because really like I'm going to have this open line of communication between the change. Now, once I've applied dimensions and everything on the drawing, I can still go back and make changes to my parts. And sometimes I have a few dimensions blow up when I do that, but generally overall, your dimensions will follow. Sometimes it's just a matter of realigning where they're connected to, and they lose that sometimes. But even if you do a bunch of work that is technically not the right dimensions, um, and if we go back and massage those parts because we are going to go back into there and look at some of the finer details that I still want to fix and it should accept those updates to your dimensions and this will be good. So I'd still say go ahead and keep dimensioning and then we'll go back and fine tune it and see where I'm different than you guys and I might find that I've got some issues to resolve too. So and then we'll just see how our dimensions change once we have that go on. So that's just kind of an overall, and then I'm gonna say an overall here. I'm just gonna pick this surface. So this is like end to end as farthest as it goes to here to here. Yeah, yeah. The other thing that people are going to want on this is I've got an overall. They may want center to center from like where the center of the inlet is to the center of the discharge, like a center to center dimension. They also would like to know maybe what the size of this inlet chute is, especially if they need to design, somebody needs to design something to fall into this. So this is a good place. And I think an ID dimension would be good. It's not, sometimes I write that in my description here. There's a local note or a specific note to this dimension. So what is it? Yeah, project from this view. Yeah, I changed my view orientation a little bit so it fit my sheet better. That's right. I did that the other day. So I got rid of that the projected top view from here, and I decided to pick up my top view above this view. So that's a pretty sweet little change up there. But I'm only going to add a couple more dimensions here, really. I'm going to add these inlet dimensions here. So to me, I like to know how wide this is on its inlet, which is going to be kind of to right here, up in this view though, maybe. So I got to kind of pick my line kind of carefully, but this is the material. What am I looking at here? Yeah, looking at that, looking at this. I should be to the end of that. That's that material. So it should be, I think, to right here should be 11. Yes, that's the dimension I should be looking for, 11. I'm just going to simplify this a little bit, say this is 11, and what am I going to add to it? Oh, that it's square. Maybe I'm going to add to the text here in front of the dimension. This is one that I don't use too often, but it's kind of a sweet little, here's the square symbol. So that just means it's 11-inch square. And then I can add a tail specific note to me. I might say ID. And I'll put this in capitals. Yeah, what I had to do is I had to like zoom in and be like, technically the inlet is 11 inches from like here to the inside material. So I did, I know there's a lot of lines. I had to come over here and make sense out of. Yeah, you can make sense out of this. This is the right here, this hidden line. This is the quarter-inch end plate material thickness with its hidden line that you can't see it through the flange, so that's hidden. But then you can see this is a hard edge where the 3/16 kind of bolt face and the quarter-inch. So this is where I actually dimension to is this visible line here, which makes sense. We're trying to dimension to visible lines, so I wouldn't want to pick this one or this one. And that's the dimension we definitely should have here. It was an 11-inch ID. Yeah, I'm going to dimension it probably down here potentially. Or I could dimension it here though as well. What is it? Yeah, I actually chose the inside material right here because, yeah, if you get in here and zoom in, you got to try to make sense out of this. This is the sheet metal part. Between here and here is my tolerance that I've designed into my part. And then here is the actual start of the flange that's 3/16. Yeah, so it is. It's like follow your orthographic projection concepts. It is interesting to how many hidden lines you're seeing here. Yeah. Yeah, and I'm probably going to forego like adding a bunch of center lines, center marks to all of these because I'm really not detailing those features here. So I'm just going to simplify this drawing and just catch critical information. What I do want is I want to know a dimension for this one, and I want one for this other end as well. And so I can dimension it here because this visible line is the inside of the discharge chute, and over here this visible line is the kind of the end of that discharge chute too. It's a little bit of a different situation. Oh, it's about the same. It's like quarter-inch sandwich with 3/16, and I'm seeing those materials here. Oh, really? Yeah. No. Yeah, remember when you click a feature and then if you right click, you get a list of other dimension types too. So we've used that a little bit. I'm gonna add square to this one. I don't think I'm putting a space between that, but I am putting a space between this and ID. And remember, I know it sounds like inside diameter, but in the sheet metal world, it kind of relates like it's an inside dimension. And it's square. So now I've just identified inlet and discharge. I've got an 11-inch ID going on, and now I want to know the distance between the two. And so I'm gonna what I would like to have is a way to pick the center of that. Whether I draw something because I don't really have probably anything good to snap to pick up that dimension. Um, and this is kind of where I'd want to do it is maybe from here to here. I just don't know if I'm going to have one that, and it should be 8 foot, I think, 96 inches, or maybe not, maybe 8 foot overall, 96. That might be right. Eight foot is maybe overall, but This definitely has a center line on it. That would be a center mark. So I probably have one on the sheet metal right here, potentially. Not necessarily there, though. Right there. That's going to be like this particular piece of sheet metal, I think has a center line where I want it, or a grip. Over here, I have a center mark here on that line. It's kind of what I'm looking to grab, even though this technically is maybe a hidden line here that I'm looking at. This is the sheet metal part. Wait, this is the sheet metal part. Coming around here, it's, I think it's this one. Let me see. For sure, I know it's this one over here. If I dimension to right there and mid dimension over here to not there, but there. 84. 0.93. I might add a local note to that, or maybe it's pretty obvious what it is, so maybe I don't need a local note, but that's just center to center. I've got my overall width. So I can have my overall length, my overall height, my overall width. I've got a few specifics, and maybe that's all I need on this. It's just kind of some general sizes. I might come back and add a few dimensions. I don't know. If I don't see anything right off the top of my that I want to worry about. This just allows the fabricator to say, once everything is built, am I hitting these dimensions? And what is, yeah. So then the next sheet down is, I think, parts, right? So maybe I'll hit my update real quick. Go to parts. That's the individual part. And now this is the one where I'm going to get a little bit specific with so this is where I have to look at a part and say, okay, identify its features and its features of size and their size and location. And I know one thing I'm going to need I'm going to need a detail of that flange bend. And this is where I have to start to determine, like what I was talking about yesterday, is that um, do I want to show these to inside bends or outside bends? What you'll find is um, I'll just come up, I think I'll do outside bends all the way around and on all my sheets. And so I'll pick my front view here. And what bends what would I dimension here? Well, I might dimension probably the radius of this, whether I choose inside or outside. It's funny, every time I think outside, then I go back and I think technically the fabricator is always like inside better. Um, let's do inside. Let's see how this looks. So the outsides will run a little bit wild, but and I won't do both, or if I do both, it'll only be like the overalls of both. So let me analyze this part and say, well, what I want to know here, well, yeah, maybe we'll say we want to know the inside dimension when this gets bent, that it's 11. Instead of being the overall outside dimension. If I did want to include one outside dimension, it might be that from here to there, but maybe I'll even forego that right now. And I'll say that's that. And then from here, this might be an outside dimension that I would like to know is from there clear down to the bottom outside here is really its overall height. And it's kind of its ID. And if my sheets get printed and it's hard to tell there, that's usually when I add those ID descriptors to that so that you can clearly, because once your sheet metal's kind of thin, it can be hard at a normal prints plotted. Is that ID or OD? And if you just add that term to this, it just helps that so much. I know it's a little bit labor intensive to always add this, but I would just add it where I need it. And I can even add it to me. Sometimes I add it on the next line down. If I want this to fit, I can just add ID right here. Maybe I would center that text or like that, maybe. Sure. 11-inch ID, then I know that that's what we're talking about. I'm not going to dimension these here. I feel like I need a detail view of this. So I think I'll cut a detail view, which is just going to be placing views in a detail. Select a view. It's this view that I want to detail. I'm following my select center point of the fence. So I'm going to just select like right here as my center point. That can be moved later. And then I start pulling out. I'm not using a square fence here. I think I'm going to use a circular fence with an irregular cutout here. You can make it a smooth cutout though too. What's that? Well, it's okay. Yeah, it's funny that mine picked B. Sometimes I don't even care as long as it's keeping. I think what I just want to make sure is I'm not using the same letter. But yeah, we could this technically you're right. I could say this is A actually. It's my first one. I don't have any other details, so why it chose B, I don't know. And then I'm just going to put this to where it's not on my object, or so I'll put my view label somewhere out here. There it is right there. I'm gonna bring it up above here as my detail. I've just got room here on my sheet. And I'm going to scale this up, I think. I don't know how big, but it's at 1/5. Here's 1/3. If I place it, I think. Yeah. And then I'll just detail the ID dimensions of that bend here. And I might decide, oh, I don't need it that big. You can always readjust these sizes, get into these grips and like size it down. But at some point, it's like I kind of need a little bit more. It's kind of a small, but yeah. And can I even get this any bigger? I don't know. 1/2 scale. The dimensions I'd be looking on this would be for sure this dimension of ID here. That one's not quite as even as some, but yeah, and I might not drive this clear over. Yeah, I'm at 1/2. I kind of went just a little bit bigger. If I can fit it, yeah. I'm gonna drag this one across like this. This might be a good place where I could either say 2x or I could say typical on these dimensions for that flange bend, because technically there is this side and this side that have that going on. And so, and I don't really need to say ID here. I think this is a big enough view that I can recognize that that is what that dimension is. I only use it where I just maybe couldn't recognize based off that. Yeah. So this to me is more clear, and but I do think I'm going to add just typical underneath it because I've got two, and to here I might add it to the side and it'll pull it out. That's my lazy version a little bit, but I think this is a good application for typical. That and that is going to detail my flanges. I've got an overall here. I need to detail I need to know what I think I'm going to put the ID dimension diameter, or it's going to be a radius dimension here. So I think I'm going to dimension this as a radius of 5.5. Yeah. And this is what I mean. If you don't left click first, you can always like right click and say dimension type. Remember, that's how you get to, if there was other things we wanted. Just don't place it before you do that. You might only be able to get to this if you haven't placed it. But I'm gonna keep mine as a radius. That's the correct, I think the correct dimension like that. I think I will add the a center mark to this though too. Like I'm gonna add this center mark like that. And I think I'm gonna add a center line down through here. It just shows that it's radiused. We'd have like a center mark side to side. I think I could pick either like the outside to outside. We'll drive a center mark through there. I just need to pull it through the part here. Those will always be based, so I'm pulling that through. And I would have the same thing here where I want to do the center mark. Um, Center mark. Can I pick that? No. Let me see. What center mark's going to work for us here? It wants two spots here. That's not the correct place though. It's actually clear up here. Delete. Yeah. This would be actually from here to here. Is that right? No, that's not correct. It's just right on that line. If I pick this as my center line, really, right? And pull it through. I'm not sure what the best center line feature for that is. I think it is this one. Definitely can. I should have access to constraints here. Let's see.
I will not say.
I don't glad they did it, but, I think that first center line one for the command, for the snap or something.
Right here.
Oh, you have to snap it. Alright,
I think it's horizontal snap, it looks like it is, but I could totally do wrong.
That's funny that.
you have to snap.
I think push create, right?
Yes, you have to right click and create. Yes. Gosh dang, some of these are ignorant. To remember these steps. Remember these steps. Yeah, that's my center line. That's my radius. I might pull this off through here like this. And I might not like this, but 5.5 radius. Overall, I'm tempted to do one more dimension here, and that really is just the it's probably just the very, very overall here. It's just an identification of, yeah, this detail is going to nestle up here a little bit. I think I can pull these down a little bit. There we go. One thing that I graded quite a bit was just remembering to stagger these. So I've got an overall. I definitely have a couple of different dimensions I could do here. I think I could add another one. If it's more clear in another view, I can move it, but I think I'm going to add one more dimension just to the overall kind of where this finishes. I'm going to the outside here, maybe there. So I'm adding this dimension in here. Need some over. So that's I'm kind of thinking that I'm done here. If I think about this part, right, I've got my radius, I've got some overall dimensions, got my ID, which is critical. I've got a detail view for the bend notes. I mean, there is more here that could be helpful. It's just I think of another one might be here to where the underside of the bend is. So I might know how long this difference is here. I don't have that entire, I can't detail that here because I've kind of cut it off, but I might add one more dimension here. And this one might go to the inside here. It's either I can choose that one or I could choose to line it up with the other dimension. This is helpful because it's kind of a straight section. Um, I'm going to, yeah. I mean, you can get kind of crazy with dimensions here in some ways because you can think of if I have to detail every little feature here, which I kind of think I need to think that way. Um, some of this is going to end up over here, though. I've got some dimensioning differences I can do here. Here, I'm going to have to dimension this little notch out and how long these are. Um,
Near the bottom of that is that when the radius kind of goes big, you'll have that.
correct. Yeah.
Yeah.
Yeah, I think it's arguable whether you need it or not. And there are some things that we can do some things to our parts to where that isn't as necessary here in some ways. Because I can put indicator marks where that is on my sheet, and we're going to do that, especially when I get to the cut file sheet, and I just think of my flat pattern. I'm gonna show you how to do just a couple manipulations to your flat pattern that allow the identification of where and specifically for this. In fact, maybe I'll just go to it right now and show you there's a technique that I use on flat patterns that prevent me from having to do all like the dimension I'm thinking about here, which is well, where does it transition from curved to straight, which would be helpful to know, especially if you have to lay this out by hand. You might need to know what that linear dimension is. And so if I had to think about that here, it would be well, I want to add that dimension then, whether I add it from where the radius starts and stops to the ID or OD of this, I'm gonna have to choose. Where I've got this dimension to that OD, I probably would line those up. And then I might have to do like a dimension here to here, and then right click and say, I want this to be like the arc length here. To get to tell someone that's the amount of material length. Like I should linearly be able to measure that when it was flat. And so that considering that the radius and how it meets the straights makes me have to add more dimensions here, or I could kind of cover my butt. And you see this in sheet metal world a lot, where we would maybe potentially forego those dimensions here, but we would do a manipulation of our flat pattern. So let me show you how that looks. What we do on flat patterns. I'm going to open up this. You just open it up, pick any view and say open. I've already got mine open. It's there. And we've already tested the flat pattern. I've defined the A side of it. So here's what the flat pattern looks like. So this is and we've addressed that we've got a notch there now. We've broken up those surfaces with our what is pretty common on these flat patterns, especially I think for robotic bending, this is less common. So if a robot's going to set my stops on how to bend this, because I think I mentioned yesterday or this week that the flange bends would happen and then the rolling will happen secondary. So there's a proper sequence in how this is going to be formed. And if a robot is handling all the bending, then it's gonna set the back stops. Like these press brakes they have little stops that essentially I have to as a handler, I have to like grab the sheet, slide it in, and hold it on some marks. I either have to like measure where these yellow lines are, because these yellow lines are just going to show up on me. They're not going to show up on the part itself. They're showing the bends and the bend extents here as they're programmed in the sheet metal defaults. And I'm going to once I do this, I'm going to say, let's take a quick break, and then I promised I would stop talking at 10, and I'm going to hold myself to that. So maybe I'll finish what I'm going to do here, and then we'll probably just take a break here. And then I can help you with wherever you're at. But I'm going to continue to dimension this afternoon for sure. I'm going to try to get my stuff done tomorrow, and I'll upload it so you have a reference. Like I said, wherever you get by the end of the weekend, just upload that so that we capture. What's that? Well, I'm also a procrastinator, so yeah. But back to what I was saying here. I can't remember what I was saying, but oh yeah, I have to hold this in here. And so if I don't have like a robot and a really fancy press brake, and a lot of companies around here still run some pretty old press brakes, and they do a lot of manual bending and manual rolling with people being the ones holding these sheets up and bending. They can still set up backstops to catch these different dimensions. I should pull up a video if you're bored. Go to like YouTube videos of press brakes and watch how the backstops adjust automatically, because you can program that equipment to do these bends. It would be set at this dimension from the edge to that center of bend. The backstop's going to go in. It's going to know, or yeah. Anyway, it's really interesting how this gets done. But in a really manual environment, which is still pretty common here in East Idaho and probably all over the country, honestly, that people are still running these fairly manual. I can set some backstops, yes, but I still have to hold up the machine with people. And what they like to see is maybe just an indicator mark on this flat pattern where that bend should start. And how we do that is we do this manipulation of this flat pattern where I'm going to do a sketch and a cut. So I'll show you. I'm just going to start a new sketch. I'm in the flat pattern. I'm going to start a new sketch. And I'm just going to pick my front surface of my flat pattern. Try to keep yourself oriented. If you forget, if you've rolled this around and you forget which is the orientation, just go to folded and then go back to flat pattern. Oh, wait, I think just go home. And maybe it's just going to be front view that I would want to go to. Just so I'm looking at the flat orientation of it like this. Start a sketch on that face. It says, edits to this are exclusively applied to the flat pattern. And that's what I want. So I'm going to say, okay. What I come in here to do is I just project the geometry, which is the center of bend line. I'm not so interested in the bend extents. That's always really the punch and the die and the press brake really are what make that happen. I want to know the center of the bend where it's supposed to be. So I'm going to project that line. It turns into a solid line. I'm going to project this line. So I'm going to project all of the bend extents, or sorry, not the extents, but the center of bend. I'm going to forego this one because there's a good, but I could put it in there. Actually, I'm going to actually project this one as well. Technically, it's the roll extent. It's just that this is the center of the roll, and all this material is rolled. And this is the transition where it goes. What I was just tripping out on that front view of my drawing sheet. This is the transition point from where it goes round to flat. And so I'm going to project that. I'm going to project this. I'm going to zoom in here and project these other center of bends. And I could have done this different ways. Sometimes I don't have to project the whole line. I could have maybe just projected the endpoints because that's really all I want is the endpoints of these lines. And I'm going to add a circle. Yep, exactly. I'm going to chop out. I'm going to put a circle right here, right on the end of that line because I have something to snap to here. And then I'm going to make this, this can vary, but I think a 16th is a pretty common 0.0625 or just 60 thousandths. 0.06 is an easy round number. What I'm going to end up doing with this polygon is I'm going to cut this little I'm going to cut that semicircle out of that sheet, and it's going to put a notch in the end of the sheet. And so when manual people are holding this, they look for those notches and they say that's where I want to, like if I'm manually at a press brake and I'm watching that punch come down into the die with my sheet in between, I have and maybe I'm up against a stop that would help. But really, even if I'm up against a stop, I can just visually watch the punch come down and hit my center of mark and know that I'm like, it helps the operator like be cognizant of an error in his stop. Like if he set his stops wrong while, or he or they, or they, whoever are doing these bends, they have a visual indicator while that punch comes down that I'm hitting the right location. And if they set their stop wrong, but they saw it coming down, they could stop the press and they could be like, oh, I've got something wrong. I see the notch that I should be hitting. And it's not lined up with my stop or something. So this is just a visual indicator. Otherwise, I have nothing. It's just a raw edge, and I would have really no frame of reference because the yellow lines really don't show up on my sheet at all when it's actually cut. And so, this is a way. So I'm just going to copy that little circle, or maybe I have to do them individually. But I was thinking I could just copy that, or do I have to? Anyways, I may have to, I'm going to copy that by its base point, center point. I may have to still define their sizes. I can't remember if I have to assign them. And I'm going to place one of these. Yeah, I still may have to I want them to be constrained. I don't want them to move around on me, but I'm trying to copy these in. Even here would be, I would probably forego putting one here. Some places might still have you put one there, but because it comes into a nice sharp corner, maybe that's obvious. So this one is like, I don't know, I'll put it there, but sometimes we would eliminate those. But I got to go around and apply these. Yeah, it's kind of an indicator for sure. But and let me just check these. I'm just going to say done here, I guess. Done. I think that these, I'm wondering why these are not constrained. As I want to try to grab these. They are constrained that way. I think it's the dimension it's coming with them, but I don't know why it's not constraining them. That one is constrained. Let me just check this. If I dimension that to this, I should be able to grab that and move that if it's not constrained. It's funny that it is. It's not movable. I don't like it though. I don't like it to be, so I may actually just end up placing a circle. It's been a while since I've done this to a cut file. So I'll go ahead and say my size is this one. I gotta zoom out. This is my size. Oh, I can't pick it there, huh? I gotta place it. Sorry. What I'll show you is maybe it won't even matter. I'll do this. I'm just gonna place a bunch of circles. The only thing that's missing is they're not dimensioned here. So because and then I will let me just test my theory here. I'm just going to set an equal constraint. This one is constrained. If I set it equal to this one, now that's constrained. So that's probably how I'm going to do this, is just place these individually. Copy is kind of annoying in some ways, especially when you're dealing with a constrained geometry. It doesn't necessarily copy the constrained geometry to the new place. If we were in AutoCAD, that would have been no big deal. That would have been great. But I think I'm just going to set these circles first, and then I'll set them equal. I'm just going to keep placing these. I have to zoom in sometimes, make sure I'm trying to grab the end of the line. So this is kind of annoying. If you really worked in a truly robotic environment, this would not be necessary. I think I failed to actually put that. So I'm just picking just random circles. By the way, we're gonna do this to all of like bent parts that are made out of sheet metal. So here I have to be a little more careful because I don't want to, which is fine. I think center point circle. I won't want it to cut the other side of this. I only want it to cut. So I'll have to be careful. What I may have to do is like do a projection and project this edge so that I can choose that side of the semicircle to cut and not this side. I don't want a notch in on this side. This is an unbent section of that. So and that'll impact this one as well. That's that bend. Oh man. Yeah. Now, when you do this much work to a flat pattern, this is when you don't want to have to redo a flat pattern. So at this point, once I've spent considerable time on a flat pattern, I hope this thing never blows up on me. Sometimes it does, and I have to go back and do this because as we've worked along, I've deleted flat patterns quite a bit while I was just testing how good they are and flexing them. So that to me is kind of an important concept that I check these quite a bit before I'm happy with my flat pattern. And then I'm going to spend some time doing some of this manual manipulation. And then I've got like 5 minutes to finish this. But what this helps me do is like not have to dimension my drawing so much either. So I don't necessarily have to be so, I'm still going to keep some of it that I've done, but now I'm going to go through and say equal. I still want my flange detail, even though technically my flange has these little marks on it to bend it. I'm still going to dimension them on that detail that I added. So I'm just adding equal constraints now. If I keep clicking around here, I think you have to pick two. This is kind of annoying. You have to pick one to make equal to the other. So I can always pick the last one, equal to the next one. Maybe if I just remember to double click it before I move on. Oh yeah. Flat patterns are easy for me to get disoriented with my 3D mouse too, but yeah, let's go here now. Open here. Then here to here, and I'm going to finish by 10 o'clock. I promise. This is the last thing I'm going to finish today, at least in class, and then I'll keep dimensioning myself this afternoon. Whoops, I messed up that. Let's go here. Just have a few more to mark. Probably if I made them bigger off the get-go, it would have been easier to do this. Because they're teeny little marks. All I'm looking for is a little divot. Um, I'd also have to think the industry you work in, this may impact it because you are kind of putting a divot in the end of it. And so probably if I was making nuclear parts or something, there might be some industries where this would not be what I'd want to do. In fact, and in those industries, you wouldn't want to etch these lines either. But there is another method that could be done is if you have a laser that can etch, maybe it can etch some of that line.
I've seen it coming out with way better that,
Is that true? Instead of being an etch, because an etch can be detrimental to some materials. Like it's such a surface, like for a lot of industries, it won't matter. Like an etched part number is great, but for high precision work, we don't want to scratch materials or etch materials. Yeah. NASA would not want that on their Artemis 2 sheet metal to have any etched part numbers that are going to have some problem potentially. Because you're compromising material with a laser etch for sure. But in a lot of industries, it's the payoff is not a problem. So now I'm just going to cut all these. And so I think I don't think I can do a cut. Yeah, I think I can actually do a cut. So cut with its thickness. I just have to select all these profiles. So here I feel like I made one mistake here and I didn't ever project. I got one more projection to do. I need to break up these semicircles on this particular flange side. So now I think I'm ready to cut. And I just got to pick all these. I got to pick all these profiles. This actually is split. That's how I want it to cut. Put a little notch in that for me. Well, as long as you have is I'd use cut, but you could do an extrude cut as well. So yeah, that one's close. Technically, that one, I guess maybe not. I was just worried that it was going to cut. Yeah, it's 30 thousandths and then it's 60 thousandths. So that's yeah. Oh yeah. Okay. I think it's because I didn't have a size, and when I dropped my circle, I was like, oh, that's going to be way too big. But yeah, you're right. I think we barely had clearance, so we didn't have to do that. Yes. So yeah, not really. That just was a perfect, fell into that one. Yeah. Another thing, because yeah, if you're working for like a third party company where you're not doing the manufacturing, this is probably somebody else's problem and with whatever equipment they're working with. So this could be, if I'm sending actual stuff to some manufacturer to build, this might not be something I even spend time with because it's like that's your problem. You built, we did the design and engineering work, and we're just going to send you the files to Cat, and you do the manufacturing. They might have to come in and do these manipulations on the DXF files or something if this is an indicator they want. What I am going to say is this is a really common indicator that a lot of places like are these indicators on where bends are going to happen. It's just a great visual. Uh, Now the dimensions on the sheet are kind of less, and so I'm going to say okay on these. Yeah, so on this little corner, yeah, I did cut it in there. Yeah, technically it is lines up with that. It is a small. It's only a 16th in diameter circle, so it's really small. It looks kind of big when I zoom in, but technically when I actually cut this part and I'm actually looking at it, you would hardly notice them unless you're looking. And a lot of them will actually get consumed in weld joints, is what's going to actually happen. Like if you think about not all of them, some of these are exposed and are just left flanges, but some of them are actually going to become part of a weld, and this little divot will actually get filled in with weld material as these parts come together to be assembled. So, oh, I don't know. Let me see. If I go back into my cut, edit my feature, I have 18. So maybe I've missed someone somewhere. Let's see here. I'd have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I feel like dance steps. 11, 12, 13, 14. Technically, I only need 14 like points. I think that I've got multiple. Yeah, you just me too. I think I had to select like a quarter of it and a quarter of it. So that's probably why I have more profiles. But essentially, if you just got yeah, 1, 2, 3, 4, 5, 6, 7, 14 cuts that are going through there. Some of them could have multiple profiles though. So yeah, that's good. That's a good point. Okay. Now this has been manipulated and I've spent time with this. And this is pretty common in other areas where I maybe would draw some things to be etched by the laser. So there is times when there's a lot of manipulation to cut file flat patterns. And then I'm really hesitant to delete those if I've labored intensely over this. Because then it's just more work that I've got to redo. So I'm going to say go to folded part. I'm going to go ahead and save that part because I've just spent some time on its flat pattern. The whole reason why I did that, and I'm going to do it to every bent part that I have, I'm going to say okay and let this accept its updates, is now I feel better about not putting those dimensions in here because they're kind of caught with a mark. And I would still need to come over here and add like some overall dimensions. So this is going to be my afternoon is just going through this thing. That was what was 96, 8 foot overall. Yeah. And then, so that's that overall. The overall heights, I think we've already addressed. We've got the two different heights over here already addressed. So I don't need to pull those, but I think I will pull dimensions here. And these, I think I will pull from the end, like sheet metal parts. If they were needing control by GD&T in a datum, I might have to think a little more critically. Here I might be a little lazier, and I'm going to say from end to end because I'm not necessarily going to GD&T these parts. I'm just going to show that this is an 11-inch cut, and then it's this dimension from here to here. I think I'll pick the OD, or yeah, right here, the OD dimension right here, maybe. I might sneak it in just right there. It's off the part. So that's really me coming this way and then coming up from there. I can think of these as pulling up from the bottom, yes. Whether this is pulling left to right or right to left, I don't know, because I'm going to add another dimension, or maybe I'm kind of almost datuming both ends of this, because otherwise I'd have to pull from here, which would be fine if I think of this, like if it was a highly controlled part, maybe I would choose here to here. But since this is such a big part, it's 8 foot long, and it's maybe less critically controlled than GD&T would in my application is going to be. So I think I'm going to say I'm going to dimension from both ends of this due to the size and maybe the uncritical nature of some of this. I mean, it is critical, but it's kind of critical from this end over and critical from this end over for the discharge and the inlet chute. I've got that kind of takes care of the center line dimension as well. That overall, What else would we want to put? Probably the difference between these two right here. And I might choose here to here. And I might place it over here, actually. Reach across that. And then I might drop this down below. 10:05. I gotta stop talking. This is what I'm going to continue on. When I get to this position, there's probably a few less dimensions I need. I might add, I'm not trying to be anything too redundant. I have the bends kind of, it's not like I really need to add the bends here because they're captured in the detail. And I've already captured the ID. Sometimes you get to this point and you realize, do I even need this view? But I think for a visual, maybe just for a visual top-down look of it. And so I wouldn't delete it yet until, I'm going to come back in and take one last look and decide if I've missed any dimensions. But right now, I don't feel like I need to add any to that top view that I haven't really captured anywhere else. Yeah, to me, I might move on to my next sheet after this. And this one I need to name though. I haven't named my sheet here yet. So I think a good name for this one is going to be housing parts. And so I'll simplify my title. I've got 10-inch screw conveyor housing. Here I'm going to say this one is housing, just simplify maybe housing parts. I'm going to have multiple sheets of housing parts. In fact, I'm just going to copy that while I'm in here. Control copy. Okay. This sheet is also housing parts. So I can actually name that right now. Get ready for my next. That one's housing parts. What is this one? Housing parts. So maybe I'll just add these titles real quick. What's the next one? Cut file parts. So that title's gonna change for me, I think. So yeah, that's a good place to stop, you guys. Yeah, stop. I'll quit talking, but I'll keep dimensioning. I will post what I have. And maybe I won't get all done either, but I'll post what I get done by tomorrow. I'll try to do it tomorrow earlier afternoon, post up my sheets at least and let you see how far I got. And like I said, just get as far as you can and upload that stuff by Sunday night.